So, next once you have understood a sentence, you are able to construct the sentence in the form of a fixed sized vector. Can I use it to translate? Okay, that is the next question, right. So, again the translation is not a very new problem, it has been there for it's been there for more than 60 plus years. Okay. So, this is what really started the machine translation process. So, this is by one Warren Weir, a researcher. In 1947 he said, when I look at an article in Russian, I say this is really written in English, but it has been coded in some strange symbols. I will now proceed to decode. Okay. So, this is what really started the machine translation in a big way. So, after this people started looking at various statistical forms of really converting the language into from one really translating the language from one to the other, and then they started evaluating methods, designing new models and so on. This is something that I thought I would bring in for you to understand this. When you start the translation process, you look at, for example, you have a dictionary. Let us say you have the English sentence as source, and then you want to translate it to French. You have a dictionary, English to French dictionary, and a French to English dictionary, right. So, if the English sentence is given, what do? You just look at that word, okay, go to the English to French dictionary and find the translation of that and then write it. So, word by word we want to translate. I do not think it will give you a good translation, especially if you translate from let us say English to any of the Indian languages. It is going to be really hard if you do a word by word translation. This sentence will not be very meaningful. Then what they did, they started creating a syntax structure. For example, English has a structure in terms of forming the sentence, right. And then there is a equivalent structure in the other language to which you want to translate into. Copy from the syntactic structure of the source into the similar structure in the target language, and then do some translation. So, this is little better, but not quite. And then you need to have this semantic understanding of that, create the semantic structure. So, these are all the hypothetical things that they started looking at, and then they found that there could be some mechanism where I can keep the source language into interlingua or a knowledge representation of the source language, which I can use it to translate into various other languages. So, this is certain theoretical approach people started looking at, and they were not very successful at that, okay, because it requires a lot of machine capability as well. So, I am sure you know that in those years the computer power that they had is lot smaller than what we have on our wristwatch right now, correct. So, the digital one that we are talking about right now has lot more power than the computers that they had in the early 50s and 60s. So, they were not able to move beyond certain points. So, we started looking at theoretical approaches that are appealing to people. Okay. So, this translation is a very interesting idea that you have, right. So, assuming that there are folks who have come from a different country and do not understand English or your mother tongue, okay, and you do not understand their language, and if you want to communicate with them, in certain fashion. You can use some gestures to communicate, but probably may be good enough for certain small tasks and so on, but not good enough to communicate certain great ideas. So, is there a way that we can create a mechanism, and when you speak in your mother tongue, it automatically translates that into the language that the other person understands, and he listens to that voice in his own mother tongue. He understands and speaks in his own mother tongue, and you get to hear that in your mother tongue when the translation finally happened, right. So, in this way you can communicate. There could be some translator sitting in front of you who is doing that job, and if you do it in real time, that will be really great. That is actually the goal of the machine translation that we are looking at. Okay. It's a very hard problem. We are trying to attempt this. So, for that we require some parallel corpora. Okay. Parallel corpora is a plural. So, we require parallel corpora, which is nothing but sample or example sentences So, you have French, so you have one sentence here, and the equivalent of that is available here as 1. Okay. And then you have translated versions available, and they are available. One is corresponding to 1, and the sentence 1 in French is corresponding to sentence 1 in English. 2 is corresponding to the French sentence 2 here, and so on and so forth. Right. So, we need to have a huge corpus of the translated version. So, that is what we call as parallel corpora. So, it should be available for the machine to learn, like we had seen earlier, right. So, we need the parallel corpora in order to really understand the translation process. So, we can do this by analogy, or you can also use a lazy learning mechanism to understand a language. For example, this language that I have here on the right side is Swahili, and this is English. So, by looking at these parallel sentences, okay, so I used one of the translation that is available online, and then I got this. Okay. So, this is my house, and then this is the equivalent of this sentence in Swahili. Okay. So, we have 1 here, this is 1, 2 and 2. By looking at the words, okay, so would you be able to translate this is my dog into Swahili? I think to some extent it should be possible, right. So, this is available. Okay. So, wherever you have this, you can say okay, and then there is is here, and then ni could be corresponding to that, and then my corresponding to this, and then house could be this, because if you look at this and here, and then or it could be the other way, because we do not know, but roughly you can translate this particular sentence into Swahili if you know, if you have parallel corpora in this fashion. So, this is a very rudimentary way of doing it, but fundamentally this what is being used in the machines for the translation. It tries to look at some parallel or alignments, what we call as okay. So, we look at the alignment of words and then try to see if we can form a new sentence given an English sentence. So, using the alignment as a table. So, I can just create a table like this. And then start figuring out how many times this occurred in English, and then how many times that particular word occurred. That will give you some idea of this is corresponding to, let us say, high in this case, okay, and then is knee and so on. And then using this table, I can translate this sentence into Swahili. Okay. So, we want to learn those models from the data that is available in the parallel corpora. So, we have two approaches that we will talk about. One is the statistical machine learning approach, okay, where we use certain language specific parameters in terms of alignment, and then we will also try to figure out, there could be phrases, right, not just one word, there could be phrases that could also align from one language to the other. So, we use two models to do the machine translation using statistical models. Okay. So, we use word and phrase based translations, and then this is one way of how can I do the translation. And then since we had seen earlier that it is possible for the sentence for the neural net to really code a sentence or encode a sentence into a fixed sized vector. So, can that fixed sized vector could be used for translation is what machine learning all about in the translation space. So, there also we look at word based models, and also we looked at alignment based models or attention based models. So, we will talk about that in detail during that lecture. Okay. So, look at this, the way we are progressing, you might have now noticed that we are not going to be looking at the natural language processing from the syntactic structure that is available. We are going to be purely looking at the natural language processing based application from the data alone. So, for us corpus is the key. So, can I learn anything from the corpus? So, everything that we have seen so far, right from the beginning, in terms of counting the number of words, in terms of figuring out how the word embedding is obtained, and then how can I encode a sentence. So, all of them are coming from the corpus side. So, we are not going to be using anything from the syntax side of the language. Okay. So, that you should be aware of. In this course, we will only be dealing with the natural language processing, and then we will only be taking the information from the data and nothing more. Okay. We are not going to be considering any grammar, syntax structure or any of those throughout the course. Okay. So, again the purpose of this is to translate from one language to the other using the neural network. The last but not the least is the hypothesis generation. This is again is a very important thing that we have not seen yet, good progress in the natural language processing. So, this is something that started the text mining. Activity. Okay. So, I will just talk about what this person did. Dr. Swanson was an information scientist who used to be sitting in the library helping researchers. Okay. So, his job was to really look at the keywords given by the scientist and then bring in all the relevant documents and then arrange them in certain fashion and then give it to the researchers. That is exactly what he was doing in the library as an information scientist, but he was a bit curious than what an information scientist. So, he was a lot more curious than any other person as a human, right. So, that is the nature. You start looking at why are these people looking at various documents, and then let me see something into it. Even though he is an information scientist, he started looking at various aspects of what he is retrieving and then providing it to the research community. Okay. While doing his activity, he actually had shown that it is possible to connect seemingly unconnected resources and form few hypotheses. So, he was actually reading all the document or the research papers that he is retrieving for the scientist, and then start looking at seemingly unconnected concepts, okay, as 1, 2, 3, 4 and so on. Okay. So, that is the curiosity, right. So, he was very curious to find out if these unseemingly connected documents have any connection at all. So, that is what he was looking at. So, actually he was looking at few concepts that are coming into his repository. So, he started looking at say for example, some of the scientists were looking at stress related to migraine. So, he retrieved documents that are related to stress and migraine and gave them those documents. He also started looking at rather there are certain scientists who were looking at stress and loss of magnesium as another research idea. And then other scientists started were looking at calcium channel. Other scientists started looking at calcium channel blockers prevent some migraine. Okay, so they seem totally unconnected, right, when you look at this. So, likewise there are several ideas, research ideas that he is helping the research scientists with in terms of retrieving the documents related to them. So, when he started looking at this, he found that each one is some way connected to the other. And then finally, he came up with an hypothesis saying that magnesium deficiency could be one of the reasons for migraine. It could be one of the reasons, there could be several possible reasons for that. That is one of the hypotheses that he had come up with. And then he actually presented that to few scientists, and they tried to really look at the details of what he has presented, and there was a research paper that claims that whatever he had found is possibly true. So, that means he is able to really connect certain things which are seemingly unconnected by just looking at the contents of the research papers, right. So, can this be replicated using the machines? As we progress, right, this kind of so as we progress in the natural language processing, we have to start moving the research towards those directions. So, this is something which I want you to look at. I do not think there is any model that are available which can generate hypothesis based on the collection of document that it finds. Okay. And it requires really the domain knowledge in order to really connect those documents. So, this is one of the very high level intelligent activity that we want the machine to perform, especially in the natural language processing. So have you seen the progression now of how we have moved from just counting the words in terms of the frequency, in terms of inverse document frequency, and then later trying to find out what are the patterns in them, and then try to find out using the patterns what could be the next word or the probability of the next word following, certain words, the prediction we try to bring in, and then later we try to really understand the context in which the words are presented in the corpus, and then later try to use that to figure out whether a sentence could be formed by combining multiple words or string multiple words together to form a sentence. And then we try to use various models to generate those. One is using the LDA, LSA to get the word embeddings, or using the neural networks to get the word embeddings. Okay. And then later try to form a vector based on the sentence, and then try to do the translation, and finally trying to figure out whether an hypothesis can be generated by looking at a collection of research documents, so on, right. So, I keep repeating this because this is the core of what we are going to be looking at in the next 12 weeks. Okay. So, also remember that whether we are really answering why using what and how. Okay. So, the why should be at your center. So, this is central to it. Why are we doing this? Okay. So, the reason why we are doing it at a very high level is to give the machine the ability to do what we do in an intelligent fashion. Okay. So, by doing this slowly and steadily, we have moved from just from the counter to learn certain things about the word, and then slowly when you come into the translation and hypothesis generation, we are moving the learning into the deep learning aspects, and then we start to provide deep learning models and so on and so forth. And then the deep learning models in turn really take us to the intelligent task that we perform as humans. Okay. In summary, if you look at this, I think I have mentioned all of this. We initially, I keep repeating this one more time. We gather statistical information about the corpus words, understanding the words from the context or context words from a word. So, both ways. Okay. So, understand the words from the context, or given the word, get me all the context words. Okay. So, that is again would be part of our lecture series. Learn to encode contextual information. Okay. So, the contextual information about a word is encoded in certain fashion. That is what we call as the embedding, right. And then predicting the next word. So, that is where we bring in the language model. So, we try to build the language model, which will try to predict the next word based on the context, and then learn to encode a sentence, understanding a sentence. So, we said we require sequence learning, and then we use a model called RNN to encode a sentence. And then we use the same model to predict how likely a new sentence could be a valid sentence. Suppose you input a new sentence, and the machine should be able to say that okay, it is 0.7 as the probability. That means this sentence is highly probable, and it is well formed as based on what it had seen earlier in the corpus. So, that sentence could be passed as a sentence that is legally valid in terms of syntax. Okay. And then learn to translate from one language to the other, and then the last one is so I won't be talking about this because we don't have material related to that as of today. Okay. So, this could be a future topic, maybe in the next 3 years or 4 years I may be talking about this.